Good day, everybody. We got an high-end question. It's a very interesting question. It's interesting because of the fact that it looks complicated, and if we are not approaching the right way or the right technique, it is a complicated question. Now, foremost, what I wish to do is I would like to make the following substitution. So let me go up here and say, first I will consider this. And I hope you're able to see the question. So let me make the substitution. Let x be equal to cos 2 theta. Then my dx is equal to differentiation of cos is negative, right? Negative sign. So there's going to be negative sine 2 theta. And you have a 2 theta there. So differentiation of that 2 theta would give me a 2 there, so followed by a d theta. So if I were to place them all, this is going to be equal to integral. I'm not going to touch the limits as of now, so let me just rewrite this. Sine of 2 times of sine inverse, that's tan inverse, so tan inverse of square root of 1 positive cos 2 theta divided by 1 negative cos 2 theta times d theta is, or I would say the dx is negative 2 times sine 2 theta times d theta. Now let me consider square root of 1 positive cos 2 theta over 1 negative cos 2 theta. Now what is this? There is a formula. Let me write that formula there. 1 positive cos 2 theta divided by 2 is equal to cos square theta. So since the 2 is not going to be in the denominator, I'm going to place the 2 here. So this is the formula that we will be utilizing. Now similarly, there is also another formula which is cos 2 theta. Now this is a block, and let me also place this in a block. So there is a similar formula for cos 1 negative cos 2 theta, which is equal to 2 times sine square theta. So we will be utilizing these two things. So this is equal to square root of 1 positive cos 2 theta is 2 times cos square theta divided by 2 times sine square theta. So the 2 and the 2 gets cancelled, giving me root of cos square theta over sine square theta is cot square theta. There is a square root there, so this is going to be cot theta. So in place of this, I would be utilizing cot theta. So let me go back to the question. So this is equal to integral sine of 2 times tan inverse of cot theta times, I need to place that. Let me clean this off and place the negative 2. I'm going to place negative 2 there, and I will have this sine 2 theta times d theta. So this is present in a parenthesis. Now one observation you need to know is tan of 90 minus theta. What is that? This is similar to, let me change the color. This is similar to tan of a minus b. So tan of a minus b formula is tan a negative tan b divided by 1 positive tan a tan b. So if I were to substitute 90 for a and theta for b, this is going to be tan 90 negative tan theta divided by 1 positive tan 90 times tan theta. Now what is tan 90 Tan 90 is sin 90 over cos 90. Cos 90 is 0, but sin 90 is 1. So we are getting 1 over an undetermined, undefined quantity. We need to set that up. So the best way to set things up is to get rid of them, because this is going to be indeterminate form, or I would say undefined. So what I would do is I will just take, I'm not going to apply the value as yet, I'm going to take out tan 90, and that's going to give me 1 negative tan theta divided by tan 90 over here. So this is divided by, I'm going to get tan 90 out, and that would give me 1 over tan 90 here, and followed by plus tan theta. Now this is tending, and okay, I can cancel these two off. Now tan 90 is tending towards infinity, so 1 over tan 90 will tend to 0. So this also goes off, and this goes off. So what are we left with? We are left with a quantity 1 over tan theta. Now what is 1 over tan theta? That's nothing but cot theta. Now I did all these things to show to you that I can write tan of pi over 2 negative theta to be as cot theta. Now this is very important. Why it is very important? More too often student will get confused, because tan 90 is actually heading towards infinity. That's why. So having given you this information, I can safely rewrite this quantity cot theta as tan of 90 minus theta. So it's going to be negative 2 times integral sine of 2 times tan inverse of tan of pi over 2 negative theta. So that is for the quantity inside, and I think I will place a huge parenthesis over here, and that is followed by sine 2 theta, sine 2 theta times d theta. Okay, so tan inverse and tan, they get neutralized, giving me negative 2 times integral. In fact, there is a 2 that I can take that. Okay, let me take that. No, let me keep the 2. 2 times of tan inverse and tan gets neutralized, giving me pi over 2 negative theta times sine 2 theta. Sine 2 theta times d theta. Right? Okay, this looks good. Let's move on. So now I would just distribute this 2 that you see here inside. Now if I were to do that, I would get negative 2 times sine of 2 times of pi over 2 negative 2 theta times sine 2 theta times d theta. This is what I have now. Now this is equal to, now let me cancel the 2 that we got here. 2 gets cancelled. So you now have negative 2 times sine of pi negative 2 theta times sine 2 theta times d theta. Now this is nothing but negative 2 times sine of pi negative 2 theta. That is going to be sine 2 theta times sine 2 theta times d theta. So this is what we have got. Now I'm going to do a trick here. What I'm going to do is I'm going to convert everything back to x term now. Now if you remember, I took x is equal to cos 2 theta, and subsequently I got dx to be equal to differentiation of cos 2 theta is negative sine 2 theta, and differentiation of 2 theta is going to be 2 with the d theta there. This is what I've got. Now I would replace everything back to x term. Why? It's easy for me to integrate. So foremost I would have to extract the sine 2 theta d theta, which is nothing but dx over 2 with a negative sign, This is my sine 2 theta d theta, followed by my sine 2 theta. Now I can have an equivalent representation for sine in terms of cos. Now if you remember, we know that sine squared theta is equal to 1 negative cos squared theta. Now if I were to replace my theta by 2 theta, this formula will still hold good. That is, sine squared of 2 theta is equal to 1 negative cos squared of 2 theta. Now I need only sine 2 theta. So from here I can rewrite sine 2 theta to be equal to root of 1 negative cos squared of 2 theta. So that is a catch here. So if I were to replace it like that, then my root of 1 negative cos squared 2 theta. My cos 2 theta is x, so this is going to be 1 negative x squared. So that is the representation for sine 2 theta. Take all of these things and substitute it here. So negative 2 times integral, in place of sine 2 theta, I'm going to have root of 1 negative x squared. In place of sine 2 theta d theta, I'm going to add dx divided by negative 2. So clearly you can see this negative 2 gets cancelled, giving me root of 1 negative x squared times dx. Now if you were to see my previous video lesson, I have given you the solution for root of a squared negative x squared times dx, where I have given that general formula to be as, I have derived this x over 2 root of a squared negative x squared positive a squared over 2 sine inverse of x over a plus arbitrary constant c. I have actually shown you how to get this. Now I will be utilizing this particular formula over here. So if I were to replace a by 1, this is going to be, so one important fact, since I brought the quantity to x, the limits stand as it is. So 0 to 1 will be the limit. That's the question given, right? If you were to see the question, it's going to be 0 to 1. That's the reason I did not touch the limits. So now I can place the limits as it is. Now if I were to translate the formula for root of 1 negative x squared, then I would have the following. So this is going to be x over 2 times square root of 1 negative x squared positive, my a is 1, so it's going to be 1 over 2 times sine inverse of x, my a is 1. Now the limits are 0 to 1. We don't have to place the arbitrary constant, we need to just place the limits. So if I were to place 1 here in place of the upper limit, so it's going to be 1 over 2 times the root of 1 negative 1 squared is 1 positive 1 over 2 times sine inverse of 1. This is the upper limit minus the lower limit. I need to substitute 0. If I were to substitute 0 in the first term, that would give me 0. If I were to substitute 0 over here, sine inverse of 0. So what is that? That will produce 0 for sine. Sine inverse, if I were to take sine inverse of 0, is equal to, say, some p. This is going to be 0 is equal to sine of p, right? Sine inverse goes over there, sine of p. Now what value of p should I place here to get 0 here? Definitely p is equal to 0 will produce me 0, at least in this case. So having known that fact, this is also going to be a quantity which will produce 0. So sine inverse of 0 in this case is 0. So all of this, they vanish. This vanishes. So we have left with the quantity 1 over 2 sine inverse of 1. That's going to be pi over 2. Pi over 2 times 1 over 2 will give me pi over 4, which is the solution to this beautiful question. I hope you like this question. Please like, share and subscribe to our channel until we meet again with another beautiful question. Enjoy. Thank you.